Hello there and welcome to this video which is going to have a look at the alkali metals and in particular what happens when you put those alkali metals into water.
Okay then, so to have a look at what happens when you put the alkali metals in water, first thing you need to do is get yourself a large bowl full of water and then with 3 different metals. Now the ones I'm allowed to show you, we have lithium, we have sodium and we have potassium, which you'll notice if you look at the periodic table, that's the order they go down. So the first thing I'm going to do is I'm going to put some inversely liquid solution in. This will show you the pH is fairly neutral. So it's that green colour. Now the second thing I'm going to do is I'm going to take a piece of my lithium and I'm going to remove the oil. Now the reason that it's encased in oil is to stop it reacting with the oxygen in the air. Okay, so I've removed that now, I'm going to pop it in and we'll see what happens. So straight away you can see it's floating on the surface. You can see that there is a gas being given off, a gas that we can test with a lead splint. So I'll show you with sodium. So we drop sodium in and we'll see the comparison. Just wait for the remaining bits of oil to come off. So we can see it's floating around. It's formed a molten ball. And you can also see it sets on fire. Okay, so what we've seen so far, we've put our alkali metal into the water. They're both floated around on the top. Sodium has moved around a bit faster and given off a bit more gas. In this reaction, what we're doing is we're producing an alkali. You can see the colour has gone purple. So we've produced lithium hydroxide and then sodium hydroxide. So the third one I'm going to show you, you should have seen the prediction that as we go down the group, it's increasing reactivity. Let's prove that with potassium. So again, I'm going to remove the oil, and then I'm going to pop it in. Now, the difference here, it's moving around faster, it's giving off a hell of a lot of smoke, and it's set on fire with that purple, that lilac flame. So you can say that as you go down the group, reactivity increases, they move around faster, sodium turns into a molten ball, potassium set on fire, and they all form alkalis, which is why the solution has gone that purple.
Okay, let's have a look at a couple of questions then. So we've got 3 here. The first one being which of the 3 is the most reactive alkali metal? So you've got sodium, lithium and potassium. Now remember in the exam you would have a periodic table. I've put it here for you. Question 2. When you put alkali metals in water, similar reactions occur. Use your knowledge of these reactions to describe how you know the order of reactivity. So what you need to talk about here is what happens when you put each of those metals in water, the ones that we've done, lithium, sodium and potassium, and how you know the reactivity increases as you go down the group. And then number 3, look at the group 1 on the right, predict what you would see if you put rubidium into water. So that's the 4th one here. Just think of the pattern, what would it look like if you put that one in there? Okay, so pause this video now, have a go at it and we'll see how you've done in a minute. Okay, let's go through. So the first question then should be fairly straightforward. As you go down the group, reactivity increases, therefore you look down the group and you see that potassium is your most reactive one. 1 mark there. As we get into the more complicated one, so it says when you put the alkali metals in water, use your knowledge of these reactions to describe how you know the order of reactivity. So the first thing you need to do is say what you see when you put them in water. All of them float on water for 1 mark. All of them move around on the water for 1 mark. All 3 give off a gas for 1 mark, and then the 4th mark is some sort of comparison between all of them. So you need to turn around and say how this one is different, which makes it more reactive. So you could have in there, potassium gives off more gas than sodium and lithium, potassium moves on the water the most, potassium sets on fire with the lilac flame, which the other 2 don't, so it is more reactive. So you need to have one of those types of statements with the qualifier saying so it is more reactive. And then question 3 then, look at the group on the right, predict what you would see if you put rubidium into water, comparing it to lithium. So your first mark is for saying rubidium is further down the group, so it should be more reactive. The second thing is for saying it will give off more gas because it's more reactive. It will move around faster, and it might set on fire or give off more flames than lithium. Okay, hopefully that video has helped then. If you're feeling confident, have a go at the review question, which is a 6 marker, which says describe what happens when you add lithium, sodium and potassium to water. How can you use this to work out how the reactivity of the group changes as you go down the group? And that ends this video.